What is interrupt in the operating system? An interrupt is an event that alters the sequence in which the processor executes instructions. An interrupt might be planned, specifically requested by the currently running program, or unplanned, caused by an event that might or might not be related to the currently running program. For example, we can consider the interrupt as a signal to stop Microsoft Word, so that a PowerPoint representation can gear up. For conclusion, you can imagine interrupts as signals sent by CPU by external devices. Normally, I/O devices, they tell the CPU to stop the current activity and execute the proper part of the operating system. Interrupts are important because they give the user better control over the computer. Without interrupts, a user may have to wait for a given application to have a higher priority over the CPU to be ran. This ensures that the CPU will deal with the process immediately. Why do interruptions happen? External devices are comparatively slower than CPU. So, if there is no interrupt, CPU would waste a lot of time waiting for external devices to match its speed with that of CPU. This decreases the efficiency of CPU. Hence, interrupt is required to eliminate this limitation. For example, suppose CPU instructs printer to print a certain document. While printer does its task, CPU engaged in executing other tasks. When printer is done with its given work, it tells CPU that it has done with its work. The word tells here is interrupt, which sends one message that printer has done its work successfully. How does interrupt happen? The computer performs many tasks known to the user and unknown to the user. And because the user may not be able to imagine the extent of the operations that he performs only when he changes the position of the mouse cursor. So the user requests many commands at the same time and he doesn't know that. So, when these commands don't match the logic of the way the computer thinks, so interrupt occurs. It could be a software error, division by zero, or request process problems include infinite loop, processes modifying each other, or the operating system does. Steps to execute an interrupt. When an interrupt gets active, the microcontroller goes through the following steps. The microcontroller closes the currently executing instruction and saves the address of the next instruction, PC, on the stack. It also saves the current status of all the interrupt internally, not on the stack. It jumps to the memory location of the interrupt vector table that holds the address of the interrupt service routine. The microcontroller gets the address of ISR from the interrupt vector table and jumps to it. It starts to execute the interrupt service subroutine, which is RETI, return from interrupt. Upon executing the RETI instruction, the microcontroller returns to the location where it was interrupted. First, it gets the program counter address from the stack by popping the top bytes of the stack into the PC. Then, it starts to execute from that address. What are the types of interrupts? Hardware interrupts. If the signal for the processor is from external device or hardware, is called hardware interrupts. For example, from keyboard, we will press the key to do some action. This pressing of key in keyboard will generate a signal which is given to the processor to do action. Such interrupts are called hardware interrupts. Software interrupts. Software interrupts can also be divided into two types. There are normal interrupts. The interrupts which are caused by the software instructions are called software instructions. Exception. Unplanned interrupts while executing a program is called exception. For example, while executing a program, if we got a value which should be divided by 0, is called the exception.